Hi, it's Gadget UK here again. This time we're looking at a CD32 again. So you'll have seen the one I picked up myself on my channel, and that was repaired over about 3 or 4 parts, I think. I'll stick some links down below and perhaps up there throughout this video. It's in excellent condition, this. This belongs to Mamemeister. Alan Stewart, a good friend of mine, one of the retro on-limb guys. You can see the label here is immaculate. There's literally just a couple of tiny little dots on it. It's in excellent condition, and the window on the CD-ROM drive there is in excellent condition as well. It's got the back cover there, so it's fully complete. From what I understand, this is not working, it's become unreliable. It's probably going to need recapping. It may need a new laser. So I think the first thing we'll do is we'll connect this up to the TV and give it a try and see how it's behaving. So it's connected up with the composite video, left-right audio, and a connector there that goes to my ATX power supply. Yeah, as you can hear, sounds okay. Composite picture's pretty clear. It probably still will need a recap unless it has already been recapped. So the next thing is to test it with a disc. Now bear in mind, it's going to find it easier to read a pressed disc rather than a burnt disc like this. I've got lots of discs I can test, including some originals. But if we just watch, you can see the print in there. It's not moving. The LED here does, however, come on. So at that point it would be tempting to look at the disc, but it's just not seeing a disc. Tried various discs here with different media, and it doesn't rotate the disc at all. So it could just be a bad laser, I think. So we'll take the lid off. It's just these screws around the outside. I think there's like 4 of them. Might be 5, might be an extra one on the front. Yeah, there is actually. Yeah, there's one in the centre there, so there's 5 I think in total. Yeah, these screws here weren't even in right, because did you hear that clip then? It's like the front wasn't clipped on properly, and that one just feels like rotating inside as if the post inside's broken off. So that might have suffered some damage at the front. In fact, there's a little chip there, can you see that? So whilst this looks in immaculate condition from the top, it's certainly seen better days on the underside. And if we flip this over, now I think it's clipped on the left hand side here with the ribbon. I don't like going inside these, it can be really annoying to get inside them. Let's just carefully lift this up here. Yeah, can you see the flex ribbon here? So this is the bit I do not like. We need to disconnect that. So in order to disconnect this ribbon, you have to lift the white plastic housing upwards. I'm just trying to get something under it. There we go, we've got it on one side. The other side is right down there. Just bear with me a minute. Yeah, there we go. I got a screwdriver just down there and kind of leave it into it and then just pulled up, and it came out and the ribbons come out, no problems. You can see that poster was on about there, so yeah, it has had an impact either on the way here or in the past. And you can see the same here, look. The screw was turning but the post has come off, so those will need sticking back on. It wouldn't surprise me if this was done on the way out to me. I'll show you the box in a minute, because there wasn't a lot of bubble wrap on the bottom. There was loads of bubble wrap on top, and then the bottom of this was literally sat on the actual cardboard box, so that's the kind of thing that can happen in transit. So I think the next thing we'll do here is unscrew the screws holding the shield and stuff and the board, because it makes it easier to connect this back up, because I do want to just adjust the pot on the laser a little bit and then connect it back up. You can see you bend those right over, those tabs. Same here, fold right over. And the ones on the back here need to go pretty much straight upwards. When you touch shielding like this, when you've worked on it, wipe it down with IPA afterwards, otherwise your fingerprints will ultimately corrode it over time. Got the screw down there, I think, and there's one down in the bottom right as well. And then if we've got all the clips off, the shielding should come up. There we go. So inspecting around that, I don't see any immediate problems. These two caps here are not bulging, but the caps are looking okay actually. I've got a cap kit for this anyway. But the main thing is, when you come to reconnect this up to test it, I've just adjusted the laser, I'll show you in a sec. You can pull the housing up really easily. You can then connect the ribbon more easily while you hold the housing up, and then you can slide the housing down like that. Far easier. So I'd work, you know, even if you're dealing with a laser, work with it without shielding off until you've got it all just right. Let's give that a try. So I'll try and show this. I've marked the top here of the pot with a little red mark, and then I've rotated it slightly clockwise and I've tried anti-clockwise. I'm just going to go a little bit further afield just in case it's really on its last legs, but that seems to be making no difference whatsoever. So if I switch it on now, you'll see it does detect the drawers shut, but then it's not doing anything. The disc is not moving. If you look at the print there, it's not moved at all. I don't hear any sound. It's almost like the CD is doing nothing whatsoever. So I'll carefully just go a little bit further the other way, so I'll go past where it was originally marked. Hang on a sec. It's not very scientific doing it this way, but right, that's quite a long way past where it was marked in the opposite direction. Obviously the key is to get the scope onto it afterwards and check the RF level, but the key at the moment is just to see if we can get any life out of the thing at all. So, same, exactly the same, not doing anything. So either the laser is totally dead, or the interface to the CD drive on the Amiga side has got a fault, or the CD drive logic, you know, or drivers and things have got an issue. It could be motor problem, it could be BTL driver, it could be absolutely anything, but it is not doing anything. So I'll just carefully lift the housing up there if I can. There we go. Disconnect the ribbon. Inspect that, looks okay. Disconnect this here. You do need this connected here because it's got the switch for the lid, you know, so that it knows when the lid is closed. I think this is actually part of the assembly here. It's been that long since I've been inside one of these. So I'll undo the screws that hold the whole drive in. If we get rid of those four, hopefully the drive will come out. I want to have a look on the top side of the drive at the gears and stuff in particular, and I want to wind the carriage back because it's right down at the moment. I want to move it away and see whether that moves. You know, sometimes drives like this in various systems can stop working just because one of the motors is jammed. So yeah, there we go, the whole thing is now coming out. The disc is still on the inside there, so there's our drive assembly. We can test it like that now actually. There's no point in putting it back in, is that? The one thing we'll have to do to test externally is to just remove the disc, perhaps just unclip this here. It might need those 3 screws removing, but that now allows us to play with the carriage here. So see if we can move it. Yeah, we can. So it's not like completely jammed, certainly not. I did clean this with some IPA and a cotton bud actually. We'll just give it another go, just for good measure. And then I think we might try it in an exposed state like this. Yeah, so again, as I say, I've already done this once already, but we'll give it another go anyway. Clean with a cotton bud and some IPA. And I'll put the laser pot back in its position up there, like that. So that's how it came to me. So I'm using an ESD safe chip carrier here. You can see, just to sit this over here, we can connect this up first. Let's do that. Let's just hold the housing up. Get the flat flex in like that. Push the housing down. Put my little scaffold over here. One thing you have to watch for is the carriage is not restricted by that. I think that should be okay. And if I switch it on now, what I'm expecting is it should either bob up and down or it should move, because we've wound it all the way up here. So let's switch it on. Yeah, so you can see it did 2 things there. It moved all the way back here and then it moved back out a little bit. That shows that it's hit the sector, you know, track 0, cylinder 0, whatever you want to call it, sensor, and then it's gone back a little bit. But what we didn't see is any bobbing up and down that might only follow the fact that it's able to detect the disc via the laser. I couldn't see anything with the naked eye there. I'm not looking at it straight on. You could blind yourself. If you were to look down on this, or even at a shallow angle, you could blind yourself. But from 90 degrees on, like I'm looking at here, you're pretty safe to do it. But yeah, it's not the sort of thing you should do. Don't take my word for it. You've got to wear special eye protection if you're looking at lasers. So yeah, there's no signs of life there, is there? Let's switch it off and on again. Yeah, it's moving forwards and backwards a little bit. Oh, I saw some there. I can see the laser. I don't know whether that's going to come out in the viewfinder. Let me put you a bit closer. Yeah, so keep your eye on that. And I'm looking through the viewfinder as well. Yeah, see the laser, the red dot? Hang on, it's off now. Yeah, there was a red dot. Let's do it again. Red dot. Gone. So the laser is there. It's a question of, is that strong enough? Let's just try a disc again. I might have to go and get one of my original discs. Maybe it's just on its last legs. Let's just try like that. Now bear in mind, I haven't got the thing on top here, so if it does start to spin, it's not going to grip. But you know what, if it starts to spin, I'd be overjoyed. Let's just see what happens this time. Nope, it gives up pretty quick. Here's a macro. See it? It doesn't look centralised, does it? Let me just try that again. Yeah, it is in the centre. So here's a little tip for you when you're trying to understand the nature of a fault like this. Is it laser, is it focus, whatever? Well, we've increased the voltage a little bit, and I know that because the red beam there is brighter. I can see that through the camcorder, not looking at it directly. Now if I switch this off and on, just watch, put the disc over it. You see it start to spin? That span. The difference is the height. I've got this nearer, so it's able to focus. Now that could indicate it's a problem with the focus coils. It's not able to go up and down there. That can happen. Focus coils, eventually can break after a number of, millions of vibrations of it going up and down, trying to follow the, the disc as the disc wobbles, etc. Eventually, one of those coils can break. It can give way. They can burn out. So I think just based on that, if I put the disc on, let's just try it with just the disc in the position there. Hang on. And if I hold it, nothing. Nothing at all. Nothing. You would feel a little bit of friction, pressure. Even though you're holding it, you'd be able to feel the motor. Nothing. I think it's not able to focus up and down. But, like I say, you switch it off and on like that, we wait for the laser, and then we bob up and down here. It's struggling. I can see it's still going now. It's still there you go. See it's turned? Just turned. So sometimes it can take a bit of trial and error, but generally, I've cycled it there, hang on. Generally, if you move the disc around a little bit, there you go, span. That shows to me that it is capable of reflecting the laser back and going, there's a disc. There's a disc, let's rotate it, let's do something. So yeah, I think it's the laser. I'll go and see if I've got a spare. So let's swap the laser. I've got some spares that are untested, so I've got no idea. We'll just remove this little metal shield here. Again, you want to wipe that with IPA after you've touched it, otherwise it'll just go horrible. Try and not lose these screws. Yeah, there we go. So it's been a while since I looked at one of these. What you've got to do here is you've got to see these little plastic bits. You've got to grab the bar and push it like that. Can you see that? As you move those little plastic bits out of the way, and then the bar slides right up here. And then, of course, if you wind the carriage as you pull the bar a bit further along, perhaps, you will be able to wind it off the edge of the bar. It's kind of there now. Need to get this bar further along. There we go. So if we just pinch those two little things together there, we can pull that gear off, I think. There we go. Can you see that gear's come out? And that should free up the drive, I think, the laser rather. Pull it back over here, off the bar. There we go. Obviously, disconnect these things. That's the mistake I've just made there. Let's just try and pull that off. There we go, that's one. That's 2. So we can put that out of the way. So I've got our new laser here. Again, I am not sure whether this works. I might have to order a new one for this, because I bought a batch of these at the time and they were a bit hit and miss actually. It's a KSS210A, as you can see there. So it's got the thing there, that's all done. Let's just check if there's an ESD blob. Yeah, it's probably there. That's the ESD blob port, it's gone. Someone's removed it already. So you have to be careful handling things like this. Static electricity can kill. So this gap here is what slides up and down that plastic. So let's just get it on there like that. And then we just need to just massage it across until it goes up the bar like that. Can you see that? And then we just need to reverse things. I need to slide this bar along like that. Just being careful here. I don't want to scratch it or anything. It gets a bit easier when you can start to pull it, look. Pull it there, that's it. That's now back in place. So that can now freewheel up and down there. We'll connect the cables in a second. We just need to get this gear back in. Now don't just force this down, you've got to get this in the right place. You did it the right place with respect to this here, but also the right place with respect to the teeth it marries up with on there. So yeah, so you know you've got it right on the black plastic here, you know, the part that holds the carriage, moves the carriage. It's just here, you need to be just a bit careful as you carefully push that into position like that. That's it, and that should now mean we can move that around, and we can. So if we flip that over, just connect the red one first. I'm guessing that the colour coordination is the same here, hence why one's red and one's white. That's it. I'm going to leave it in its default pop position for the moment. Let's connect that up and give it a try. So again, a little bit of initial trial and error with the laser voltage, and I got it to start to spin. I held the disc there like that, and it started to spin, so I knew it was detecting the disc. So at that point, I've unscrewed the 3 screws that hold that onto the lid, which means we can clip that on there. It's a magnet, and if we switch it on now, hopefully you'll see. Give it a sec, it's looking at the disc now, spinning. That's an audio disc. And we got the audio player, so that was super easy actually. The problem may be trying to dial this in now to get it perfect, but I can get the scope onto it. Yeah, that's working fine. So let's unclip that. Yeah, garbage. I love garbage. So my wife tells me, well I do, the band Garbage. It's a Scottish female lead singer. I think she's a brilliant singer actually. It's pretty dark music, but yeah, it's really good. Anyway, let's get that shield back on, and we'll just wipe over it. Yeah, so there's nothing else really we need to do with this now other than just clean the laser lens when we're finished. We can get some grease. Let's do that actually before I do that. We'll just get a little bit of grease into that carriage because it's a brand new kit. This black piece of plastic here with the teeth along it is new. There's no grease on there. So I was pleasantly surprised that that laser works actually, because I got, I think, three of these. One of them I already marked as questionable. So I must have had some issues when I was trying to get mine working using those lasers. Yeah, I'm just getting a little bit of grease onto the other gears as well, so we'll just rub a little bit of that up there. And then we can just carefully rotate this carriage here. I'm trying not to get it all over my fingers. I'm bound to get it all over my fingers. And then we can wipe off the excess in a minute. And we'll get some on this rail as well here actually. Let's just wipe the excess off. Nice and slow, because if you go too fast you will break a tooth off somewhere. You get a little bit on there as well. Again, like that. You see it slipped there because I went a bit too fast. That's it. And then we'll just, for good measure, get some in there. Might need a bit more. Just at the point where those two join there, like that. That's it. And then we can just wipe the excess off here, like that. I'm just going to wipe my fingers with a bit of IPA here, just because you do get little bits of grease all over your fingers and I just don't want to get that everywhere, so my hands are clean now. Let's now get that shield back on. Which way around does that go? These 3 screws here. The ones that hold the the spindle thing on the top are a little bit bigger, so don't mix them up if you've got the 3 from here and the 3 from that in a pile somewhere. And as I say, can you see these smeary marks? That will corrode that if it's not removed. So we'll wipe over that with some IPA. And around the outsides as well. Just to disinfect that from me. And the screws for that, they've got like a countersunk thing. Can you see that? Yeah, they are like a countersunk style, even though they aren't countersunk, which is a bit strange. I guess it helps pull it at the point where the counter bit goes into the metal hole. You can't quite see what I'm doing there, but I'm putting the first one in. Doesn't really help that I can't see what I'm doing in here. It's shocking how dark it is in here today. I'll get it through there first, and then I can just kind of line it up with the hole, I think. Yeah, and then just loosely tighten that while I position the others. Anyway, I'll report back in a minute. So, I have not been looking forward to this part, if I'm honest, just because there's so many blooming caps on these CD32s. Now, the kit, I haven't sure if I've shown this kit before, I may have done actually. It's from RetroBench. This is a fantastic place, a fantastic company you can buy cap kits from on eBay. You can see lovely quality caps, I'll have a look in a sec. And they come with this really nice diagram here that tells you exactly, you know, it's colour coordinated, the size of them in terms of microfarad rating, the voltage and stuff, and you can tell from the polarity which way they go around on here. So this is really, really useful. There's 2 sides to this because there are a few different revisions. I think there's a 4.1 board, isn't there, where things might be subtly different. Yeah, there's like a block of 4 there on the 4.1. But on the Rev 3 and Rev 4, you can see you got 1 little gap and then 2 there, so it kind of corresponds. Yeah, so I can't recommend those guys enough. Now, they sent me a cap kit, a couple of cap kits actually, just after I lost my job. One for a CD32 and one for a 1200, because those were 2 of my own systems that I want to recap, so those will be a future video. And they'll be cut down because I've done a few recaps of these now, but now this is the second one of these I've done. I did one of these for Tom Mead on a live stream. We used hot air and it took blooming ages to get the caps off. Granted, I didn't add any additional flux, which is one of the things that can obviously help you big time when you're trying to remove these things. But with this particular one, I think what I'm going to do is use my 2 soldering irons and actually heat both pins up at once, try and hold it and just like pull it out of position, because I suspect I could go through these fairly quickly in terms of the removal. The soldering them on doesn't take that long once you get into the zone, but taking them off, yeah, I think I'm going to try with 2 soldering irons. It's a technique I've talked about, never tried it. So I'm going to add a little bit of solder onto each tip of each iron. I don't envisage this being easy. It's like I say, we're trying a new process here. It's a theory. People have talked about it in the past. I've had 1 or 2 people go, why don't you use 2 irons? It's so much easier. Well, it is if you're really dexterous with your hands. Let's give it a try. So let's get ready on the pad. Heat that pad and that pad. Let's try this way around. Yeah, there we go. So I think I've managed that without any pad damage there, and I didn't have to heat. Once I got into the right position there, I didn't have to heat for very long. Let's just see what those look like. Yeah, they're fine. They're fine. Got a little bits of solder there, look. I need to clean that up now. Anyway, I think that that will be okay. I think I'm going to be able to do it that way. The other benefit of doing this, because we haven't had to superheat this with hot air, you can see the pad's fine, there's nothing leaked out. Now, I had a few people in the past go, oh well, you can't go off these caps when they look fine like that. You know, you remove them and you find they've leaked underneath. I think that when you use hot air, these leak anyway. It expands and then it just kind of bursts its guts from the underside and leaks out just under where it is. But you can see they're using 2 irons. That has not leaked. So this is the thing. I suspect on all of these here we're going to see the same thing. We'll check them all on the ESR meter anyway while we're at it. It's always nice to see what its capacitance rating is, but also what its ESR is. Anyway, I'll just continue that way. We'll add a little bit of solder onto each one first. just because it's got a bit of flux in there as well. And we'll just see how we get on. There might be the odd one that this technique won't work on, depending on where they're located. I don't know, you know, I might not be able to easily get 2 irons in, like, you know, getting down there is pretty hard. Anyway, let's try with these. Let's use my wobbly hand on that one there, and that one there, and lift it off. Look at that. Yeah, this is going to be a breeze, an absolute breeze. So yeah, my recommendation to you, I don't know if that was off shot there, is use 2 irons. If you have 2 irons, try it with 2 irons. You get them off in no time. What I wouldn't do is twist them or cut them. There are channels that show cutting them. You know what? Yeah, if you get good at it, you can achieve it, and you probably won't damage anything. But it is just a risk. Why take a risk? It really is one of those, you know. If you've got a beloved system like this, why would you want to risk damaging the pads? That seems to be the quickest, easiest way to get them off, in my mind. And again, let's just have a look under those. Bone dry, absolutely bone dry. There's a funny colour there, let's have a sniff. It smells alright, so anyway, we'll continue around that way. I'm pleased though, because this has changed my perception of doing recaps. If it's this easy to get them off, I could do this in no time. Let's just try those the other way around. Because one of these, there you go, one of these has got a better tip than the other one. There we go. Let's try this one down here. These caps are really annoying. There you go, they kind of hinder. It's almost there, hang on. It's the there you go. It's the negative side that's holding it. There's not as much thermal capability on the Antex as there is on the Heiko. Let's try these the other way around. Let's put that one on there and this one over there. Yeah, there we go. The key, I think, is that one side absorbs more heat than the other. I will have to inspect, obviously, very closely around here just to make sure. I've not bridged anything and that sort of thing. The main thing is you've got to inspect closely after you've done any work on these, just to make sure you don't get any solder particles or anything bridging anywhere where you shouldn't have it bridging, just to heat each side. So it's starting to move. Oh, I've messed that up. One problem you can have is if you just move it a little bit like that, then you position it in such a way that you can't get onto the pad. So the key here is just to maybe just move them sideways a little bit, like that. You see it starting to twist, starting to rotate, and then just lob it off like that. But obviously do inspect to make sure you've not got solder where you don't want it, etc. One of the other benefits of doing this rather than using hot air, as you saw when I did I think the CD32 on the live stream, some of these things can move around if you're not careful. You know, you heat these caps up here, all of these are loose, and obviously they're all exposed to additional heat. Everything around here is cool because the only part we've been soldering there is just the pads. Because as you can see, it just makes such light work of it, it really does. Yeah, so I would say it's taken me about just less than 10 minutes to get all of those SMD caps off there, right up to the top here, so I can't get on the board because we're so close. Yeah, no problems at all. Got no rogue bits of solder, not heated anything nearby, not damaged any connectors. It's amazing how quick that was. So I'll just get some braid, dip the braid in some flux, and then just suck the solder off these pads so we can start to put the new caps on. So I'm going to use the, you can see what I do is I just literally dip the braid into the tube there. It saves you putting loads of it on the board and stuff, but I'm going to use the crappy iron here, you know, I'm going to use the really bad iron here, the Antex, just because it's out and it's got a wider tip on it. I just cut the braid down there. There's obviously a lot of solder on those pads there. There we go, that's those two done. There's a pad there but there's no cap, so you've got to be careful you don't end up thinking you're missing a cap when you aren't. Yeah, what I need next is some self-cutting braid. A little tool or something you can use where you can just press a button or something and chop it off. That would be super useful for speeding up things like this. Those pads don't look good, so maybe that cap leaked. It's come off now. It's just like a little bit of oxidisation on them that makes me think those were corroded. I'm not expecting every cap is going to be alright when we come to test them, but you never know, they might be. So I'll be honest, I think that took twice as long cleaning up the solder off the pads with braid than it did actually removing the caps. It took ages to do that. It's because you've got to keep cutting back the braid. Anyway, I'm going to clean up as I go along here, because we're not going to have all this excess flux everywhere when we actually come to solder the caps on. Yeah, the pads there, as I say, there's a cap that's not actually fitted on these boards. So I'm just carefully cleaning off the flux. Right, there we go, whole pad's cleaned up, flux removed. Yeah, the one thing I'm not happy about with this kit, it's got a tantalum there, look. All the others are okay, but anyway, there's nothing really wrong with using one tantalum on there, it'll be fine. You should, though, try and use electrolytics, you know, where you can, really. Replace like for like. So there's just that one that's a tantalum, which is a bit strange. I'm not quite sure why they've gone with that. Maybe it's a case of they couldn't find the right, couldn't get stock of the size. The tantalum is to replace one of the ones on the board here, but I'm not going to replace that. That's going to be fine, I'm sure. I might do it. Let's just do all these ones first anyway. So we'll start with these big ones because they're going to be easier to do, I think. So 100 microfarad. And I've shown this before, this sloped bits on the side of the positive side of the can. The band there is the negative, and it's a square flat edge on that side of the black plastic. And it mirrors up the silk screen here. All of these, the polarity is marked correctly on the board. It's just the two through holes back there that can be wrong. So, yeah, just get it onto the board. Try and get it as centralised as you can, so it looks nice and straight and it's on the pads. Of course, you could just solder the pads first and then use hot air and introduce it, but these big ones, dead easy. Look, you can just flow solder on the pad and it goes up onto the pin. Remove the solder from your tip and just come across the other side and do the same thing on the other side. And then if you just dab into these when you've got no solder on the tip, you will resize the solder point there. We've already got flux because the solder contains flux, so other than just resizing them like that, there's nothing else to do. That one's done. So I'll show you one or two of these as I do them. I've got them positioned as straight as possible, touch the pad, flow a bit of solder. It's the same stuff you've seen me do before, same on the other side. And we'll try and just hold it down while I reflow these as well, just to make sure it is flat and flush, and then resize the solder points there. If you want to see a longer video than this to do with recapping, I'll do one in future on my CD32, but there's also the one I mentioned earlier to do with Tom's. I'll stick a link to that above and below. But bear in mind, when I did Tom's, I really should have added a little bit of flux to remove the caps. And removing them with hot air is nowhere near as easy as I've shown in this video. That is not sitting very flat there. The solder's alright, the pads are alright. I think it's just because it's a small cap. Anyway, I'll try and get that into position. Just push it up a little bit. One problem I've got is this tool is magnetic. So you can just about see that. I can't. Even on the LCD it's hardly visible. It's quite hard because it's quite small pads on that. There we go. I'll just hold it and reflow, and hold it and reflow. Final cap. So I've positioned the camera there so you can just about see that. I'll test these one at a time here. You'll see many of them are okay. Like that's 100, it's got 0.86 there on its ESR. That's good, I can tell you that's good. Hang on. Yeah, so testing it a second time, you can see that's good. And in fact, that's what the ding ding indicates. If we try some of the smaller ones though, you will see these have completely changed. One of them is terrible, one of them is like 9 ohms or something. It's quite hard to get a reading. There you go, 6.1 ohm. Let's measure that again. 5.8 ohms, so you can see the 4.7s, yeah, they're bad. Even though they're okay, they haven't leaked, the ESR is dangerously high on those. Hopefully the reflection's off that. So I'll try another one of these big ones again. That doesn't read properly. And you can see that, 0.92. So the hundreds are okay, the 4.7s are problematic. Let's just do another 4.7. And I can tell you that that's exactly what I found throughout the sizes. The hundreds are all okay. The tiny 4.7s, look at that, 6.8 again. So you could argue that maybe it's in spec for the, the caps that we used at the time. I don't think so. I don't think they would have been 6.8 ohms at the point these were new. I'm sure they have aged and the ESR's changed. Another one there, 6.2. You can see it again, one on the 4.7s. Now there's another one here somewhere, another small one, and it's like 9 ohms. Let me see if I can find it. I remember this one. This one had some discoloration on the underneath of it. No, that's the same again. Around 6.2 ohms, that one. A 4.7. So the 10s are around the 2.5 ohm mark. So again, yeah, a bit higher ESR than you would perhaps like, really. You want less than an ohm, really. But obviously there's a relationship to the voltage. Let's try that again. So these mightn't be far off what they were when they were installed. There you go, 2 ohms on one of the 10s again. But none of these have leaked. That's for sure. There's no leakage. If you look at the underneath that base there, can you see? It's solid plastic. There's nothing on any of them. So yeah, they haven't leaked. That's the 47, look at that, less than an ohm. And it seems to be the case, all the 47s, that's exactly what I'm getting on all of them, they're all okay. That's 22, its microfarad rating's a little bit low, its ESR's not too bad, 1.78. But still, it's higher than if you were to get a brand new low ESR caps. Because they will be usually less than an ohm. There's 100 again, 1 ohm. Yeah, so I tested every single one of those. There were no anomalies. It was literally, all of the 100s had the same proximate ESR. All of the 47s, all of the 22s, all of the 4.7s, all of the 10s, etc. There was no real variation by, I don't know, 5% in between them, like the same range, same voltage and the same microfarad rating. So those caps, you could argue, didn't need replacing, but the ESR is the clue there. The ones that were like 2.5, 3 ohms, ultimately they will fail. So even though they're good on this now, or they will fail eventually, and I suspect it's going to be the same thing on my A1200 and my CD32, because neither of those have got leaked caps, and I guarantee if we remove them the same way as this, none of them will have leaked, and I suspect we're going to see the same thing. Anyway, let's get these remaining caps off here. There's only 4. Got the 3 electrolytics there and that tantalum. I'm going to use 2 irons again to remove that tantalum. We'll see how easy it comes off that way. Just saves me heating the wider area with hot air. It's a nice touch actually, adding the tantalum in there. It's perhaps not the sort of cap you would think to replace as a part of a bit of preventative maintenance. You're probably going to need to increase the temperature here. Yeah, that's not going to melt, is it? Let's just crank the temperature up a bit. But that's what you need, because you've got pretty thick rails here. Yeah, that seems to have done it. It's got blocked again. There we go. Chunk of solder in there. The cap should be pretty much free now. Let's just try and heat it and pull it. The solder is off there, but there's probably just perhaps a little bit on the top side holding it. There you go, it's free on that side. Yeah, that side is not as free. There we go, it's out. Let's do that one again. And that's out. So that's that one out. We'll check the ESR of these as well, but there's nothing really probably exciting to show you because these were the right way around. So I'll just clone around those 3 caps there. I unblocked one of the holes on that one. Can't unblock that bottom one. You can see I've removed as much of the solder off it as possible, but couldn't get it off. It's incredible how much heat that's absorbing. The larger ones were no problems at all. So let's get these ones in. That's one. Negative, I remember, and the negative goes towards the switch here. It's the easiest way to remember. So like when you put this one here, it goes there. Yeah, there we go. Just add a little bit of solder to each. And then what we'll do is put a bit of pressure from the other side, just to keep it nice and flat, and let the heat soak through to the other side. It does take a while because these are really thick traces on both sides here. You can feel from the temperature of the cap. If you feel the cap's still stone cold, you know it's not been heating long enough, because the heat will then spread up the leg. There you go, it's just starting to get slightly warm, just a little bit. Yeah, as the heat spreads up the leg through the board, once it's spread through to the other side, you'll feel the cap just go lukewarm. Anyway, you've seen me do one. I'm just going to do exactly the same thing on the other 2, and then clean up the pads with cotton bud and some IPA. I'll just reflow that. It looks a bit big after cutting it. That's it, we're all done. So I'll clean up around these caps, and I can get the motherboard back in. Yeah, you can see that is dirty, but it's probably just fingerprints and things more than anything, because the cover looks like it's never been removed off the back of that. Anyway, that'll do for that side. Just wipe it dry and then do the other side. I'll get a little bit onto each side here, it'll just assist. So we'll try the Antex on this side first. There we go, look. Nice to flip it upside down. That's all you need to do. If you can get it to go upside down like that, then you can literally just pull it off. Let's just heat that. There we go, most of it's off. Just give it one more pass. Oh, good God. It's quite hard trying to hold. It's quite wide, that. Yeah, that'll do. So I'll just clean the pads there, I'll inspect it. Bear in mind these tantalums don't leak, they just short over a period of time. So there's our tantalum. The band goes to the left, so it should be dead straightforward, and the band designates the positive on these. You'd think it'd be the negative, wouldn't you? But yeah, it's just going to go like that, pretty much. It's not that essential if this is not 100% straight. We'll just have a go at add a little bit of solder down here. Yeah, that'll do. And get a bit down here. And then I just need to just reflow it, make sure it has joined the actual cap. A little bit of flux again. I can always wipe this again in a sec. Yeah, looks nice on that side. It's quite hard trying to get in down here. Looks nice on that side. And just out of interest, let's ESR test this tantalum. Now you may think you can only ESR test electrolytics. That's not true at all. I've tested tantalums before and I found a short, high resistance on an Archimedes. Let's just do that again. You can see that's super low ESR, look, 0.38, nothing wrong with that tantalum at all. But it's in the kit, so why not replace it anyway? So the second new laser has arrived. The first difference straight away, look at the size of the box compared to the old one. When I was ordering this, I was like, oh no, it looks like the same as the one I'm already fitted here. Now I did ask the seller, does this definitely work with CDR media, burnt media? And he said yes, no worries at all, and he was curious as to where I'd got mine from. You can see the different, it's got a different coloured PCB, and I think the lens there is reminiscent of the original one. Let's just compare to one of the ones I've got here. So this is one that I marked with a question mark, because I wasn't sure from testing whether this was much good. Now the one that's fitted works perfectly with press discs. Yeah, the lens is about the same if you look at the colours of them. This one's more glossy though. Can you see it's like clearer? That one there, yeah, I'm not sure if that's going to come across. They're different, very subtly different, but the PCBs are very different. Can you see that? And the mechanism here is made of a different plastic as well. These have definitely come from a different factory or something. Let's compare the diode. I think this is the diode, and I think the pickup is this piece here on that little PCB. The different colours look, and that might be part of the issue here. If you've got a different pickup or a different laser, it's going to behave subtly differently. Anyway, let's have a go at fitting this. The ESD blob is still on there, can you see that? So what I'll try and do is just use the braid here on the ESD blob, see if we can remove it. And I'll just test on continuity just to make sure. That cap there is at an angle, isn't it? It was like that obviously when we owned it. So the meter's working. Let's just touch the pads here. Yeah, no join. That's good, so we can install that now. Yeah, the laser in particular I've got on there, there's a huge difference. Can you see that? Can you see how blue that looks? Look at that one. It's just black. There is a difference there. So I don't know, the lens is different, and that on its own can make a huge difference as to the media that these things support. So yeah, this will work in any drive, like a normal CD player, an audio drive, where you need a KSS210A. It will be fine. If you're going to use original discs on it, it's going to be fine. But burnt discs, that's not going to work, as we found. So I did have to reduce the voltage level to the laser there. I think it was a little bit too high actually. It was struggling to read. I just turned it slightly anti-clockwise, and straight away it was working with the press disc at that point. So I've tried a burnt disc and it's worked straight away with a burnt disc. No worries at all, it loaded it really quickly. So the disc has only been in about 7 or 8 seconds, and straight away we got to that point. So yeah, that's fantastic. I think I'm going to buy a couple more lasers from this seller actually whilst they're available, because these are really good compared to the ones I already had. It also explains why my CD32 is not that great with some of my burnt discs. So the other thing I need to do here is stick these posts back on. We've got one there, and you can see one here. I'll show you the box this came in a minute. There's nothing wrong with the box, but the bubble wrap at the bottom of it. So here's the box with the CD32, and you can see this is the problem. It was the upside down, and this bubble wrap was on top. So there's nowhere near enough bubble wrap, so I'll stick a load more bubble wrap in this before it goes back to Alan. So I need to solder a wire onto the RF test pad. It's here. Where my thumb is, it's just marked RF0 on the silk screen there. So I've got the scope on AC coupling here. It's on ×10 there for the impedance. What I need to do is just get this to one block. So I've got it on AC coupling there. I'm just going to adjust the probe. Hang on, there we go, to straighten those edges a little bit. Yeah, they're a little bit curved. Bear in mind, we've not got a ground connected at the moment. But what we're trying to do here is just get it to one block, as you can see there, is representing 0.2 volts, 200 millivolts. And I'll connect the hood here just with a clip, because then I can clip that to the wire I've soldered to the RF test pad. We'll connect the ground up to the drive ground, because that is connected to ground as far as I remember. And switch it on. Now it's got an audio CD in there at the moment. I'll just wait for that to start playing. I'll have to mute the TV as soon as it does. Hang on a sec. Right, that's muted. If we adjust the time base, yeah, there we go. So you can see our RF level, we've got 200, 400, 600 and a little bit. So that's actually quite low. I was expecting to have to get nearer to a volt there. Yeah, what I want to try and do is get nearer to a volt if I can. I'm assuming that this is a good ground. I can test that in a second. But you can see the pot is right under here. So if I just turn that clockwise slightly, just a tiny bit, let's just see what effect that's had. And I'll start playing a track. Yeah, you can see that's gone up, look. If we just move that so it's on the level of one of these lines, 1, 2, 3, 4, 800 millivolts. And just checking the drive chassis there is grounded, as you can see. The board's not even screwed in, and we've got a good ground. Same on the motherboard. So I think we're all fine there. I'm just going to test it with a CDR again, and just make sure CDRs work. So the way I've left this, with a press disc, it's just around a volt. So you can see we've got 1, 2, 3, 4, 5 divisions there. I've gone slightly higher than I did on mine, just because, well, of this particular laser, but also it's the fact that Alan's going to be using CDRs on this, and that boosts them up a little bit to around 650, 700 millivolts level. I found it's reading a variety of different CDR discs better at the level it's at now. So yeah, 1 volt is probably what they're configured to from factory. You could go, if you're going to use press discs, you can go a bit less than that. Burnt discs, you need to go slightly higher. So I'm not going to show you me reassembling this again. I'm going to do all the same things. I've greased up the rail again, greased up the gears and the new piece of plastic there on the carriage, and just going to get this cover back on, wipe over it with IPA, get it all back together. What I can show you is how to get this back on. So you need to feed the ribbon carefully through that. You could detach it from the actual PCB, but it's easier just to feed it through like that. Can you see these little metal clips here? So I'm a bit close there. If you hook that first one on, rotate this around. Be careful not to touch the lens while you're doing this. And you can see these clips here just go over. So in order to get inside these, you just have to just lift here, just gently. Can you see that? It's over the clip. And you do the same with that one, and it hinges up there. Just make sure you feed the ribbon through. But as I say, you could disconnect the ribbon there. You could pull it out, but I don't want to do that. Anyway, that's back together. We just need to get the single goldish colour screw into there. All the other ones for the case are all like a silvery sort of colour. There's a couple of tiny spots of corrosion here on the shielding. Got a really good deal on some WD-40 recently. I got it from Tesco. It was like £2.75 for a giant tin. You try and buy it for that in the shops. It's impossible to find at that price. Anyway, you can see that's a lot better. Still a little bit ready there. Can you see that? I'm just going to go over that just a little bit more. That's it. We're back to good metal again there now. So I stuck one of the labels in here just to show it was recapped. I put 11th of the 2nd, 2021. Technically it was about 4 or 5 days before that actually, but it doesn't really matter. The year and the month is the main thing. And under where it says where it was manufactured in 93, I've stuck the other label here. It's not cut straight, but I didn't cut the top part of that. It was already pre-cut before it came to me. The main thing is someone knows from the inside and the outside when it was recapped. So all reassembled. I've tested it a number of days now. Everything works perfectly. The CD drive works, straight away as soon as you power it on. It works with press discs and CDR. So I do hope you found that interesting. I know we're covering old ground here because I covered a CD32 before, but if anything, there might be a few tips there regards the focus. The thing I showed at the beginning with the putting the disc manually over the laser and moving it up and down, but also the technique that I've developed, I guess you could say, in terms of using 2 soldering irons. I talked about that idea in the past. but it came into practice in this video, and it was made super light work of it. I spent literally 10 minutes removing every single cap from the board. It was incredible how much faster that was. So Alan, Mamemeister, covers various systems on his channel. He does lots of comparisons, you know, certainly on the 8-bit games and things. Arcade Perfect My Arse, I think, is the title of his videos there. Those are the ones I really enjoy, actually, but he does lots of live streams and stuff as well, covering mostly Commodore 64 games and things like that, but other systems as well. You know, he covers games on the multiple platforms there, so it's worth checking his channel out. If you would like to support the channel, please see the Coffee and Patreon links down below. I'll catch you in the next video.